Hey, what's happening, guys? It is summertime and the living is supposedly easy. Today we're going to take a look at this. The Venlab VM-500 multimeter. Going to have a nice look at it, see what she's got to say. But first, let me just do a little housekeeping. So it's Monday. You guys are watching this at the 26th of June. Well, guess what? I'm not really here. I'm having surgery. So this week I have pre-recorded some videos, and this is one of them. Also, I want to go into thanking everybody who helped me with my 3D printing so far. I showed you guys this the other day. The bolt I thought was too tight. I didn't have enough clearance. Well, it's fine. Just needed to clean up the threads a little bit with a file. So, all good there. Alright, let's open up the Venlab VM-500A. Batteries. Warriors. AAAs. Oh, look at that. Extra fuses. You don't get that very often. Good job, Venlab. K-type thermocouple. Printed manual. Another thing you don't see very often. Oh, it's got data hold. Backlight, flashlight, auto power off. Can we turn the auto power off? Yes. If you press the function button and turn on the power meter, the automatic shutdown will be canceled. Very nice. So we have non-contact voltage. DC-AC voltage, resistance, continuity measurement, diode measurement, capacitance, frequency. Oh, and duty cycle as well. We're going to play with that. Oh, right. Battery measurement. Nice. DC-AC current measurement, temperature measurement. This is a 6,000 count meter. Runs on 3 AAA batteries. Update is 3 times a second. Fuse protection, 600 milliamps, 250 volts, 10 amp, 250 volts. Voltage between terminals and earth ground, 600 volts. It is Cat 4, supposedly. Alright. Let's have a look. Magnetic, very nice. And we put in our batteries. I like the size of this. This is what I would call like a 3/4 or a half size. It's not as big as your full-size Fluke, but it's significantly larger than a little pocket beater. Hang on, once I get these batteries in here, I'll show you what I mean. So, surgery's no big deal. It's just a, 55, almost 55 years old, so a little bit of maintenance work going on. But if I don't come back, well, thank you all you guys for watching this stuff. I originally created this channel back in 2016 when I first found out I had congestive heart failure. And I just wanted to leave something behind for my son because I had nothing left behind from family members who went. So I thought I could leave behind an electronics education for him and share it with all of you as well. But should be good. All right, hang on. All right, what I was telling you about sizes. So here is our Venlab we're looking at today. Now this is what I would call a full-size meter. It's about the size of, you know, your standard flute type. And then there's your smaller pocket meter. So you can see how it fits in the realm of things. I like this size. I like the way it feels. Alright, now as engineers, when we're testing something, we want to eliminate as many variables as possible. So when we look at multimeters, we do not test them with the leads they came with. Not that there's anything wrong with those leads. We test all our multimeters with the same set of leads. That way we have eliminated the possibility of different leads imposing resistance, reactance, inductance, whatever, into our test. We know these are about 0.02 ohms of resistance. These are the Probe Master gold-plated probes. Here is our AD584 voltage calibration device. So let's turn this on. We're going to put it in voltage mode here. It's already on DC. Let's turn on the lights. I don't know if that helps you at all or not. And we should see around 2.5 volts. 2.506. Whoops. Okay. Let's go up to 5 volts. 5.01. 7.5 volts. 7.51. 10 volts. 10.02. Alright, so at 2.5, we're looking at 6 thousandths volt off. At 5 volts, the error's in the hundreds. 7.5, the error stays in the hundreds. Yeah, okay. So we have no error larger than 100. Very, very good. Okay, now we're going to go and we're going to test resistance. So you can see I have a resistor set up here: 1 ohm, 10, 100, 1000, 10,000, 100,000, 1 meg. You know they're not going to read those though, right? So 1 ohm, 0.9. It's like a 10% error. Let's see what the other ones are. This is 10 ohms. 0.6. 100 ohms. 1,000 ohms. Man. I'm going to have to go and test these resistors with another multimeter. Otherwise, I'm not liking the error rate on these. Alright, we're back. It is just manufacturing tolerances on these resistors. I tested this with 2 other multimeters, and this is within 1% of all the other ones, so that's fine. I was getting worried, as you could probably tell there. Alright, let's test some capacitors. I have 2.2 microfarad, 3.3, 220, 470. So we'll go function. Well, that's our continuity. Let's do a quick continuity test. All good. Oh, diode. We can check our diode here. I have a Schottky diode sitting right here. That's not reading like a Schottky. Hang on. Bear with me for 1 second, please. That came out of the drawer labeled Schottky diodes. Let's try another one. You know, just wondered if maybe I have mislabeled them. For anything is possible. Yeah, those are silicon diodes. Mislabeled. No problem. We'll continue with our diode testing. I have some LEDs here. Depending on the voltage it puts out, it should light them. And it'll definitely tell us what our forward voltage is. Assuming I get the wires in order. Okay, so 1.8 forward voltage, and it lights the red LED. Perfect. 1.86 lights the yellow. 2.3 lights the green. 2.55 lights the blue. 2.6 lights the white. So we can deduce that our diode test voltage is somewhere right around 3 volts. Now, what else we got here? Oh, our capacitance. Okay. All right, let's do our capacitors. So this should be around 3.3 microfarad. 2.2. Can you hear that? Okay, that 2.2, there's our 3.3. So we're right on. So here's our 220. And our, what is it, 470? Yeah. Looking good all around. All right, now this also has a frequency. So let's try this in a couple different ways. All right, I've got the function generator set up for a 10 kilohertz sine wave. Let's see what we get. 10 kilohertz sine wave. Take it down, make it a 1 kilohertz sine wave. Beautiful. Let's change the shape. Let's make it a square wave. And let's take the frequency back up. 1 second. Okay. 10 kilohertz square wave. No problem. How about a triangle wave? Yeah, I still got no problems picking that stuff up at all. So excellent, excellent. Now I want to check out this battery testing. This should be interesting. Okay, so I grabbed a couple batteries. Here is a cheap Chinese heavy-duty AA battery. It's reading good. Now here's something interesting. This is a AAA lithium battery. Let's see how it reads. Yeah, it reads fine. I don't have any 9 or 12 volt batteries. Alright, let's move on and do some current testing next. Okay, got the power supply set up for 12 volts at 5 amps. And this is a, well, you can read that. It's a 50 watt, 50 ohm wire wound power resistor. Often find in audio systems. So we're going to take the positive from the power supply into there. Then we're going to take, coming out of the resistor, and that is going to go to our milliamps, because this should be around 200 milliamps. And then we'll take from the back side of our meter, the out of our meter, and we will attach that to the in, or the return, the ground, whatever you want to call it, the power supply. So basically we just have a series loop going here. Alright, let's energize and see what we get. 237 milliamps. No whackers. Alright, let's move over here to the 10 amps. Not that we're going to be able to get 10 amps, what we're going to end up getting is about 600 milliamps, I'm guessing. Oh, over 600 milliamps, rather. So we do the same thing, out of the power supply, into the resistor, out of the resistor, into the meter, out of the meter, back to the power supply. And energize. And for some reason, it's not reading anything. And I don't know why. That might not pick up until it's... Oh, because I'm in milliamp, Paul, you dimwit. There we go. I know that's really hard to read. It is kind of dim. So far, that light is my only downside to this. Alright, let's not cook anything. Alright. Let's see what she's got under her skirt. First things first, you gotta remove the condom. And that ain't always easy. But if you just work at it, you will persevere. There you can see the magnet that's placed in there. Very nice. Very nice. Okay, so we'll take off the battery compartment. Let me get some more light so you can see better. Remove these screws. For anybody that's wondering, I have not forgot about the barking dog project. I'm getting ready to move it on the Vero board here, as you can see. And we'll get to that once I come back from the surgery. Assuming I don't die on the table. Well, it's not actually a table. It's more like a chair, really. A very maneuverable chair that they can move all over the place. Come on. I'm trying to be gentle. If you weren't watching, I'd have this thing apart already. Hello. Okay. All in all, I like the design. Let's go look. A little camera adjustment so we can see better what is going on. Since we have our inputs here, battery contacts here and here. This is our 10 amp fuse. It's got a nice wide track there, going right to a 5 ohm resistor as a shunt. Interesting. Usually in multimeters you'll see like a piece of copper, bent copper, that's cut to a precise size as a shunt. That's interesting. So there's the other side of that, and you can see it goes through a ventilated track to the ground. We have a nice big PTC here. Our fuses are glass. They're not ceramic. That's a bit of a downside. NCUL, non-contact. What's the UL for? Let's see if we can get in there and you guys can see it. Yeah, there you go. NC, oh, VO, non-contact voltage level. That makes more sense. Don't mind me. What we got? What? 8 megahertz crystal. There's the antenna for our non-contact voltage, which is a piece of metal that is just floating in the breeze back here, flapping in the breeze. That should be secured with some sort of adhesive. Sounder, MOhms resistors, big old diode. Yeah, I have no problems with it for home use, hobby use. Do I believe it's Cat 2 600 volts? I could have swore that manual said Cat 4 600 volts. Or the box or something. Somebody said Cat 4. Let's start with the box. No, it says Cat 2. I must have misread it. My bad. Let me reassemble. So yeah, I didn't test the non-contact voltage. I didn't test the temperature. They generally just work. It's not an issue. And besides, you want to know how much this thing costs? It's $21 off of Amazon. I put it in my store. I'll put a link down below. If you need a multimeter, you can't beat that for 21 bucks. All right, guys. If you enjoyed this, I hope you'll give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. Big thanks to Venlab for sending that out. That's it. I'm out. Peace.